Okay, we are going to do best fit lines today. We've already looked at best fit lines a little bit. This is just to kind of help us get into the groove here. So do a couple more real life type examples. So it says on our first example, Rob collects coins. Over a 3-year period, he collected 1,000 nickels. So that's how much is in his collection. They're going to keep referring to that as the sample. So the sample is just Rob's coins, okay? After organizing them by year, he found out that the number of nickels from a given year was related to the number minted that year. So over here, this is Rob's collection. So it doesn't tell us what the years were, but he had 7 coins that were all from the same year. And then he looked up how many were minted that year, and there was 3.4 million. So that would be 340 million if you wanted to write that out. Just, I'm not going to write all of those out with all those zeros. There's a reason they took the zeros off, and that was to make the math a little easier. But this is how much was minted that year, how much came out of DC or Denver. We mint coins in Denver. So how many were minted that year, and then how many he had in his collection, and he's looking at the relationship. So the first thing it says to do is create a scatter plot. So I've went ahead and put a graph on here for us. Our X is going to be the coins minted. So coins minted in different years, and these are measured in 100 million. So we'll just write that there. And we don't need to go any higher than 20. There are 20 boxes going this way. So if you count 1, 2, 3, 4, 5, I'm just going to mark them at the 5, 10, 15, and 20 marks. So each box is worth 1. 1, 2, 3, 4, 5. I'm just choosing to only mark some of them to save us a little bit of time. Then the Y value is going to be how much is in Rob's collection. So this is the coins and what they're calling the sample. And it goes up to 50. So since I have 20 boxes going this way, I'm going to make them worth 3 each, which means I'm going to top out at 60. Halfway, it's going to be 30. And if you want to mark all of these, you can. So this would be 3, 6, 9, 12, 15, 18, 21, 24, 27. We hit the 30. 33, 36, 39, 42, 45, 48, 51, 54, 57, and 60. Okay, I know some of you are not that fast at writing, so this might be a good time. I'm going to zoom in for you. This might be a good time to pause the video and just make sure that everybody has that graph set up. Okay, I'm assuming you've paused and got everything over here set up. We're going to put our points in. So we're going to start with 3.4 and 7. So I'm going to go over 3.4, which is almost 3.5. So it'll be between 3 and 4, say about right there. And then go up to 7, which is just a little bit above 6. So about right there. Then I have 6.4 and 13. So this would be, there's 5, this would be 6. 6.4 is about 6.5. We're going to go up to 13, which is a little bit above 12. These are little boxes, so I'm not going to go a bunch above 12, just a little bit. 10.3 is just a little bit past 10. I'm going to go up to 25, which is just a little bit above 24. And then 11 is this line after 10, and it's going to go up to 31, so a little bit above 30. 15.3 is a little bit past 15. It's going to go up to 26, which is a little bit below the 27 line. And then 17.4 is about 17.5, so 15, 16, 17.5. Go up to 57, which is this line up here. Okay, if you need more time to plot those points, pause the video, get it all in there, but I'm just graphing points, x and y. All right, I'm assuming you've already paused, that you are going to, that you're good, you're ready to do the next part. So on the directions, create a scatter plot, check, we did that, it's over here. Okay, now we're going to describe the correlation. So it looks like the dots have this upward trend. As more coins are minted, there are more coins in Rob's collection. So since this increases, makes that increase, that would be a positive correlation. So we're going to write the word positive. When we draw our line, it will have positive slope. So when I look at this, it looks like these are almost in a straight line, and then there's this one kind of out here, not really in line with the others, and we might consider that to be a bit of an outlier, which just means it doesn't fit the rest of the data. So this might be considered an outlier. An outlier is kind of an outsider. And so what we might do is just kind of look at these points and try to fit a line that kind of goes through those. So maybe I'm going to go through these. Let me think. I might, because that's in there, I might skew it just a little bit this way. This is what you do with your ruler. You kind of go back and forth and go, okay, where's going to be the best place so I can hit a couple of lines and, or hit a couple points, I mean. Have a line that hits a couple of points and doesn't leave a whole lot out. So if I connected the first and the last point, everything else would be below. That would be a bad decision. If I connected this point and this point, which is kind of an outlier, I'd have a bunch of points above my line. That would be a bad decision. So I probably want to connect this point with one of these in here. That's probably my best bet. Let's just connect. Let's connect those two right there. And later I will teach you how to use the calculator to factor all of these in, although the calculator always factors in the outlier too. So I drew it, and I do have 2 points above and 2 points below. I'm going through this point, this point. That's what we will use for the next part when we find the line of best fit. So we drew the line of best fit, but now we need to write an equation. It says find a line of best fit. We really now need to write the equation. So the points that we use, this first one was 3.4 and 7. And the second point that we used was over here, and that was 10.3 and 25. Sometimes I'll round those off to make the math easier, but we're just going to use a calculator and it'll be fine. So to find the line of best fit, the first thing we need is to figure out the slope. So we'll use our slope formula. We'll take 25 minus 7, 10.3 minus 3.4. So 25 minus 7 is 18, and if I subtract those decimals, I get 6.9. That is not a very nice looking slope. We don't usually leave decimals inside of fractions. So in this case, what we're going to do is we are going to divide those numbers using a calculator. So I'm going to set my calculator up here beside, and I'll show you. I'm going to type in 18, hit my division key, 6.9, and then this is what I'm going to use for my slope. We're just going to use a decimal. And so I'm going to round that off to just 2.6. Since I had one decimal place up here, that makes sense that I keep one decimal place there. Okay, so that's my slope. Then I need to pick one of these points that I chose to go into my point slope equation to write my equation. So let's just pick the first point. So I'd have y minus 7 equals, my slope's 2.6, and x minus 3.4. So that's the point slope equation, and then we can distribute and clean it up a little bit just to make it easier to use. So if I take 2.6 times x, I get 2.6x. If I take 2.6 times 3.4, I get 8.84. I'm going to round that off to 8.8. And then over here I still have y minus 7. So we can clean this up a little bit further, solve for y, add the 7 to both sides. We get y equals 2.6x minus 1.8. So that will be my answer that I will put over here. All right, so it says, what does the slope represent? So if we think about what we did up here on the graph, we were using these 2 points. The slope is rise over run. So we had this point and this point. So in generic terms, it's showing us as the coins in the sample are going up, the coins that were minted are also going up. Or as the coins that are minted go up, the coins in the sample go up. So that's really what the slope represents. It shows the increase in sample coins as the coins minted increases. That is not a sentence, it's more like a fragment. But basically it's showing us how the coins in the sample, let me show you the picture again, the coins in Rob's sample go up as the coins that are minted go up, which makes sense. If they made more coins this year, Rob should have more coins from that year. This year they didn't make as many, Rob doesn't have as many. That's basically what it's showing you. And then on E it says, what does the y-intercept represent? The y-intercept is always a beginning point. So in generic terms, if I didn't think about it, it would just be the starting point for coins. We really don't have years here, so the y-intercept is a little bit interesting. If we look at our graph, our y-intercept, we'd have to extend the graph down to the negatives, and it's about negative 1.8 down here. It's a starting point for our best fit line, and it would technically be the number of coins he would have in a year where they minted absolutely no coins. So there's a couple ways you could think about that. So if you're being very literal, you would say it's the number of coins in the sample, which is the number of coins that Rob has on a year, not years, when 0 were minted. Now, we actually got a negative number for that, and that's because there was no year in the sample where no coins were minted, so it doesn't exactly make sense. As far as our equation goes, it's just where that line starts at the y-axis, but the y-intercept is usually a beginning point. It's where, so if there were 0 coins minted, he would have negative 1.8 coins. It's kind of a nonsense thing, but that's what it would represent. It would have been nice if that had hit at a positive number, but I couldn't make that work. Okay, on F, using this model in a sample of 1,000 nickels, just like Rob had, how many would you expect to be from a year in which 8.4 million were minted? So this is an X value, the way that we set up our table and our graph. And they're wanting us to look and see how many would be in the sample, which is y. And then we're going to round your answer to the nearest whole number. So we're going to take this equation, and they're giving us an x value, so we can just put that in. So 2.6 times 8.4 minus 1.8. And if you put all of that into your calculator, you'll get 20.04. We're going to round that off to the nearest coin, and so you would expect 20 coins to be in that sample of 1,000. So if this is Rob's coins, you would expect him to have 20 coins from that particular year. We don't know what year that was, but using the information they give us, that's what we would have. Okay, on G, it says a sample of 1,000 nickels contains 30 from a particular year. According to the model, how many would you expect to have been minted that year? So they are giving us 30 in the sample. That is Y. And then they want to know how many would have been minted. How many would have been minted, and that is X. So this time we're going to take the 30 and we're going to put it in where the Y is on the equation, on the other side. So 30 equals 2.6x minus 1.8. And then we have to solve that equation. So we're solving for x. We're going to get rid of the 1.8 first. Add 1.8, which gives us 31.8 equals 2.6x. Divide by 2.6. Divide by 2.6. And we get 12.2 something. It says round your answer to the nearest tenth of 100 million. So we're going to keep the first decimal point. That's a tenth. So 12.2. And we'll just write the words 100 million. And that's how many coins you would expect to have been minted in a year where Rob or whoever has 30 coins in their collection of 1,000 coins. Okay, so let's do one more example. So if you switch to the other page, we have this. The cost of a flight is related to the distance traveled. So if you look at this, the further you travel, the more your flight's going to cost. I want to know what airline this is because I feel like this is pretty cheap. So miles is going to be our independent variable. The cost is our dependent variable. Why? Because the cost depends on how many miles we actually flew. So this goes all the way up to 2,250. We're going to have to figure out how exactly we want to number this. So we do have 20 squares going this way again because that's how I designed this. And so we can just figure out how that's going to fit. So you could take this and divide by 20, but I don't think that's going to be a nice number to use. Yeah, 112.5. Probably not a good number to use. Another thing that we could do is just go by 500s and kind of fake it. So let's do that. So let's see, I'm going to go 2 squares and say that that's 500, which means that another 2 squares would be 1,000, 1,500. Oh, I didn't put the 0 in my 1,000, sorry. 2,000, 2,500. Technically, that'd be far enough. I'm going to go ahead and do 3,000, and you could keep going if you wanted to. And this is the miles flown. And then on the side, we're going to have the cost in dollars. So I always put that dollar sign on there so we know it's not pesos, rubles, pounds, something else. And we need to go up to 260 on this side. So if you think, 300, 400, we need to go a little past that. Let's count that side by, trying to think. I think we can go by 20, can we do 25s if I go 2 spaces? Not quite. Okay, let's make 2 spaces 50 then. 2 spaces 50, 2 spaces 100, 2 spaces 150, 2 spaces 200, 250, 300. So we've technically gone far enough. I'm just going to go a little further, 350. Okay, if you need more time to do anything, I'll zoom in here on the graph and you can pause the video, put more in there, try to figure out what my writing says. So if you need to pause now. I'm just going to keep moving. All right, I'm assuming you've paused. Everybody has the graph set up. Let's go over here and create a scatter plot. So we're starting at 225 and we're going to go to 53.9. So half of 500 is 250, so 225 is going to be just a little bit less than that. And 53.9 is just going to be a little bit above the 50. We're just going to fudge that, put it about right there. 1100 would be just a little bit past 1,000. 135 would be about right there. Halfway between 100 and 150 would be 125, so it'll be in there somewhere. 1375, this would be 1250 right here, so it's going to go a little past that. Go up to 113, which will be about right there. 1675 would be past 1500, and then 163 would be past 150. Not going to get real exact points here, we're just getting it in the neighborhood. 1950 will be just below 2000. 179. This would be 175 right there, so a little bit past that. And then 2250, this would be, let's see, this is 2000. 250 would be just right on that line. I just had to check that in my brain. And then 260, about right there. So that's where our points would go. So we made the scatter plot. Check that off. Number 1. Describe the correlation. The more miles you fly, the more it costs. So this is also a positive correlation. Sometimes we get negative, sometimes we get positive. Find the line of best fit. So I probably should have spread this out a little bit more, but it's okay. We're just going to put a line that goes through these points. So I would not want to connect these two because then all of my other points are below. Kind of want it to go through the middle somehow. But I like to use points that are out of my actual data. So let's see. Maybe if I use this point in one of these, about that point and that point, does that work out? It's pretty close. It'll about hit 3 points that way. It's going to come close to 3 points. I actually didn't get my line quite through the points, but we're going to say that I did. Actually, it looks like it's going through this point more than that one. So I probably got my line a little bit high. Try that again. So I could re-record this, but it's actually good for you guys to know that if you get it on there and realize it's not quite right, you don't want to have more points below the line than you do above. So I'm going to try to fix that again. So I'm going to try to go through this point and this one over here. Try to get my little protractor lined up. Okay, that looks a little bit better. And I'm actually close to 1, 2, 3, 4 points there that are basically on the line, and there's one above and one below. It's probably as good as we're ever going to get by hand. And then find the line of best fit. We drew it, so now we're going to write the equation. That's what I mean by find it, not just draw it. I also mean find the equation. So I might actually use a couple of these points that are close together in the middle because I think they're closer to the line that I actually drew. So this one is 1100. I'm having issues here. 1100, 135, and this one is 1675, 163. That's what that one is right there. So I'm using these 2 points. I could use this one if I want. They're all so close. We're going to get close to the same answer. And I will tell you that when you're doing homework, that if different people use different points, your answers will come out a little different, and that's okay, because we are estimating. All right, so if we find our slope, we take 163 minus 135, 1675 minus 1100. Did not work this one out ahead of time, so I'm going to do a quick calculation here. So we're going to get 28 over, I should have done that one in my head, over 575. All right, and again, because this is a story problem, I'm going to use my calculator. I'll put this calculator up here and show you we're going to change this to a decimal. So I'm going to take 28 divided by 575, and we're going to round this off. I think I'm going to keep a couple decimal places. So see where that 4 is? The next number is an 8. I'm going to round the 4 up to a 5 and get 0.05 for my slope. And I didn't space this very well, but that's okay. I'll just write small. We'll zoom in. I'm going to take one of these points now. Let's just use the first one that I used and put it into the equation. So I'd have y minus 135 equals 0.05 x minus 1100. Same formula we've been using. Seems like forever. So I will have 0.05x. I'm going to take 0.05 times 1100, and we get minus 55 over here, and then we're going to solve for y. So add 135, add 135, we'll get y equals 0.05x plus 80. Just double checking my work. So I'm going to write that equation over here since I was sort of getting sloppy, and you can always use another sheet of paper when you do your assignment. That way you don't have to squeeze it all onto a worksheet, but I'm trying to get this all in the notes. So I went over here, since you couldn't see what I was doing, and I wrote that equation next to the question, find a line of best fit. So I wrote it over here. What does the slope represent? So if we look at this, we're going up dollars and over miles. So this one is actually really easy to explain. The 0.05 means it's going to be $0.05, which would be 5 cents per mile, not miles. So that's a rate of change. Remember when we first learned about slope, we did rate of change, or the dependent divided by the independent. And so this one's actually really easy to explain. It's 5 cents per mile. And then what does the y-intercept represent? If you look at your graph, it's not starting at 0, it's starting up here, and we just figured out that that y-intercept was 80. And so basically we're adding, actually let's think about it this way. If we think about it, all the way over here, that would be 0. So 0 miles, we're at $80. So that would be the cost of 0 miles, which happens to be $80. So that could be some sort of starting cost. They're adding $80 to every single flight, regardless of how far it is. So that's sort of a starting value that they're just using, some sort of extra fee or something. Okay, using this model, what would be the cost of a flight that travels 800 miles? So miles, we said, was X. So we're going to put 800 into this equation for X. So we'll have 0.05 times 800 plus 80. So 0.05 times 800 plus 80, and we get 120. Remember that this is a cost, so we're going to label that with dollars. So it would be $120. Then it says what distance corresponds to a cost of $69. So they're giving us a y value. We're going to put this in where the y is. So 69 goes on the other side of the equation. We have 0.05x plus 80, and we're going to figure out what that mileage is. So we solve this just like a normal equation. Subtract. It doesn't look right, does it? So we're going to get a negative. Well, let's just find out. So we get negative 11 over here and 0.05x over here. Okay, so this is a bad number. 69 is not what I wanted. Let's change it to 99. I know everybody's groaning right now, but I want this to actually work, and I don't feel like starting over. So we're going to put 99 there, which will give us a positive 19. And that just works out better. Divide by 0.05. Doing that on my calculator. And we get 380, which is a nice number for X. So remember, we're asking what distance. So this is 380 miles. We should label that.